Hello friends, CNC technology is not new to us, but during last few years, CNC machines are available at reasonable price. So you will find various CNC machines in any engineering shop. So we must learn CNC part programming for lathe and milling machine. It is not very difficult if you understand the logic behind it. You can make CNC part program very easily. In today's lecture, we will learn the basics of programming for CNC lathe having Fanuc OT Control. I am NM Chakradev. I have more than 25 years of experience in CNC part programming and machine operation for various controllers such as Fanuc, Siemens, etc. Now we will discuss the working principle of CNC machines. In simple language, CNC part program means instructions given to the machine in coded language. Once we execute this program, the machine control system decodes these instructions and generates necessary commands for various slides. Also, some machine functions are also activated. Finally, we get the job of desired shape and size. The slide motion is continuously monitored by a feedback system. Machine stops when target or program point is achieved. This is the simple working principle of CNC machine. Now we'll discuss the axis designation system for CNC lathe. Generally, CNC lathe has two axes, longitudinal axis that is Z axis and transverse axis that is X axis. However, some CNC lathes having live tools have more than two axes. So axis passing through lathe center is Z axis and axis perpendicular to Z axis is X axis. In making the CNC program, we take program origin point on the center of face of the job. So this is program origin point. So from this program origin point, all the coordinates towards right are Z positive. And from this origin point, all the coordinates towards left are Z negative. All the coordinates from this origin point towards up are X positive, and all coordinates from this origin point towards down are X negative. While taking XY value, we take X value as diameter of the job, not radius. So this is important. So in CNC lathe, diameter programming is used. Now we'll discuss various codes for CNC lathe part programming. First is O. O refers the program number. We can give maximum 4 digits as program number. N is block number. One block means one line of the program. We can give maximum 4 digits as block number. G is Gcodes, that is geometrical functions. These decide how the tool will move. Gcodes decide the size and shape of the job to be manufactured. Next is X. X is positional data, that is the absolute distance traveled by tool slide in X-axis direction. Z is absolute distance traveled by tool slide in Z-axis direction. U refers to the incremental distance traveled by tool slide in X-axis direction. W refers to incremental distance traveled by tool slide in z-axis direction. R is radius value. In addition to this, R parameter is also used in different CAN cycles which are used in CNC lathe programming. We can define the radius by giving R parameter, that is radius value, or we can define the coordinates of center point of radius. So I is the center point coordinate from start point in x-axis. K is the distance of center point from start point of arc in z-axis. F is feed rate. In some cycle, that is in threading cycle, F parameter is used to define the thread pitch. S is the spindle speed. When I say S 1500, then spindle will rotate at 1500 rpm. T is for tool call. When I say T0505 means 5 number tool with offset number 5 is called. Next is M codes. M codes are miscellaneous codes. These are the machine related functions such as coolant on, coolant off, spindle motor clockwise or spindle motor rotating anticlockwise, etc. These G and M codes we are discussing separately in the next part of the video. P is subprogram call. In CNC lathe part programming, we use subprograms. For calling subprogram, P code is used. Also in some cycle, some CAN cycle, the P parameter is used. Q is also parameter used in different CAN cycles used in CNC part programming. The semicolon, this is the code for block end. Block end means end of that line. So semicolon uh, makes the different lines of the program. So semicolon is as block end. Now we'll discuss the various G codes for CNC lathe programming for Fanuc OT Control. First code is G00 or G0. This is used for rapid positioning the slides. In the start of program, we bring the tool at the safety point away from the job with rapid feed rate. Also at the end of program, we retract the tool away from the job at rapid feed rate. This rapid feed rate is 20 meters per minute, 60 meters per minute, depending on the size of the machine. So one should be careful while making program with G0 or G00 code. Next is G01 or G1. Actual machining takes place with G1 or G01 command. This is in linear interpolation, that is movement in straight line at program feed rate. So after G1 or G01, we should give feed value and target point. G02 or G2, this code is used for defining movement of along circle in clockwise direction. G03 or G3, this code is used for defining movement of tool along circle in counterclockwise or anticlockwise direction. In some operations, we want that spindle should run, but feed movement should stop. So in certain cases, we have to define dwell time. So G04 or G4, this code is used for defining dwell time. G28 is the code for reference point return. At the end of program or at the start of program, we send the tool to the reference point. This is the point where indexing can be done safely. G40 is tool nose radius compensation deactive. This G41 defines tool nose radius compensation to the left. While making program for contour or taper, we should define the position of tool, whether in the direction of cut. If tool is on the left side while moving in the direction of cut, then it is G41. When tool is on the right side when we see in the direction of cutting, then this is G42. When we use constant cutting speed mode, then we should define the maximum spindle speed. G50 code is used to define maximum spindle speed. G94 defines feed in mm per minute. G95 is code used for defining feed in mm per revolution. G96 is constant cutting speed mode. In this constant cutting speed mode, as the diameter reduces, the spindle speed increases according to constant cutting speed defined by us. G97 is constant spindle speed mode. When I say G97 S1500, then spindle will rotate at the speed of 1500 rpm irrespective of diameter of cutting. Now we'll discuss important M codes for CNC Lathe programming for Fanuc OT Control. First is M00. This code denotes unconditional program stop. Here machine will stop and we can do some operation like inspection or deburring. So here program will stop. Next is M01. This is optional stop or conditional stop. On machine control panel, there is one button for optional stop. This button should be on, then only machine will stop when it will read M01. So this is optional or conditional stop. M02 is program end, but there is difference between M02 and M30. This is program end, but no return to the program top. So cursor will be there at that point only. M03 means spindle rotation clockwise. M04 denotes spindle rotation counterclockwise. M05 denotes spindle motor off. M08 code makes the control column motor on. Column motor starts by M08 code. M09 means column motor off. M30 is end of program and auto rewind. So cursor will go to the top of program. Again we can start the program beginning. M98 is subprogram call and M99 is subprogram end. Reference point is the point where indexing can be done safely. G28 command causes the tool to go to the reference point. When we start the machine, the tool position may be anywhere between headstock and tailstock. G28 is the code for auto return to reference point of the machine. Combined meaning of G28 and U0 is to send the tool to the reference point of x-axis, and combined meaning of G28 W0 is to send the tool to the reference point of z-axis. Now we will discuss the codes G40, G41 and G42. These are the important codes for maintaining the correct size and shape of the job. The collection of G40, G41 and G42 codes allow machine controller to produce arc and tapers on the workpiece very accurately. By considering the tool nose radius shape, without tool nose compensation, the profile cut by the tool nose would be undersized or oversized depending on the type of operation, that is internal or external. If we use sharp tool, then there is no use of tool nose radius compensation. But in practice, there is always radius in the nose of the tool or at the tip of the tool. So we must have to compensate this value. If we don't use proper compensation, then there is chance that workpiece may get undersized or oversized by this amount. So code G40 is used for cancellation of tool nose radius compensation. When viewing from machining direction, if tool is on left side of the contour or job, then it is G41. When viewing from machining direction, if tool is on the right side of contour to be machined, then it is G42. So while making CNC program, we must give proper tool nose radius compensation, either G41 or G42. As a thumb rule, generally for external operation G42 is used, and for internal operation G41 tool nose radius compensation is used. G94 and G95 are the codes which define the feed rate in CNC part programming. In G94 mode, the feed is defined in millimeters per minute. Generally, for milling operation, feed is specified in per minute. Hence, G94 code is used for CNC milling programming. In G95 mode, the feed is defined in per revolution. Generally, for turning operations, feed is specified in per revolution. So, G95 code is generally used for CNC lathe programming. In the programming for CNC lathe, the spindle speed can be monitored either by G96 or G97. G96 is the code for constant cutting speed mode. Here, diameter as the diameter reduces, the spindle speed increases as per the formula of cutting speed, which is pi dn on 1000, where d is diameter of job in mm, and n is spindle speed in rpm. Cutting speed value is in meters per minute. So for profile turning operations or stock removal operation, we need that as the diameter reduces, speed should increase. So when we use G96 code, we have to define the cutting speed value. According to cutting speed value, the spindle speed will increase or decrease depending upon change in diameter of the job. For some operations such as drilling, threading, we need constant spindle speed. G97 is the code for constant spindle speed. When we write G97 S1850, that means spindle will run at constant spindle speed of 850 rpm irrespective of change in diameter. Now we'll make a program for this drawing. In this drawing, diameter is to be reduced from 25 mm to 23 mm for the length of 35 mm. So one step turning and one facing operation is there in this drawing. So we'll make CNC program for this drawing. Now we'll make CNC program for this job. In this job, diameter is to be reduced from 25 mm to 23 mm for the length of 35 mm. First we will take a cut on face and then we will make program for one cut on diameter. So first of all we have to give program number O1234. In Fanuc OT Control, O is the code for program number. Any 4-digit number you can give from 1 to 9099. Any number you can define as program number. Then first block N1. N1 means first line of the program. G28 U0. Initially tool may be near headstock or tailstock, so we need to send the tool to the reference point for x-axis. G28 U0 means send the tool to the reference point for x-axis. Then block number 2 G28 W0. Now we will send the tool to the reference point for z-axis. G28 W0 means send the tool to the reference point for z-axis. This is the position where indexing can be done safely. Block number 3 G50. G50 is the code for maximum spindle speed definition. In CNC turning, if we use constant cutting speed mode, then as the diameter reduces, the speed increases. But by G50 code, we can reduce the maximum spindle speed to a particular limit. So G50 is maximum spindle limit definition. S2000 means spindle speed will not be more than 2000 rpm, and here we will define spindle direction, that is clockwise. M03 means spindle direction clockwise. Then we'll define constant cutting speed. G96 is the code for constant cutting speed mode. We'll define this as 120. S120 means cutting speed will be 120. Means you know formula for cutting speed. Cutting speed is equal to 5 dn upon 1000. Here cutting speed is in meters per minute. D is diameter of job, N is RPM. So as the diameter reduces, the spindle speed increases. So G96 is code for constant cutting speed. Now we will call the tool T0707. T means tool number, 07 is 7 number tool. On turret different tools are mounted. From those tools we have called tool number 7, and next 07 is offset number, and here we'll start the coolant motor. M08 code is code for coolant motor start. Then we'll first position tool to the safety point. So G0 Z0. Next we'll call the tool in X direction but away from the job surface. So X28. Diameter of job is 25, so we have position tool 3 mm away from the diameter. Now first we will take cut on face. So here I am using G01 command, linear interpolation, X0 and feed 015. So tool will take cut on face up to X0, and then will take the tool away from the job, that is Z5.0. Now again we will position the tool in X direction. So G0 X 23 mm. Now we'll take one cut on diameter. So G01 Z minus 35 F.15. So tool will take cut on the diameter, and again we will position tool to the safety point X28. Now our machining is over, so we will send the tool to the reference point G28 U0 and M09. We'll stop coolant motor. Then we'll send the tool to the reference point for Z axis. Now we'll deactivate the tool offset T00, and last block is M30, means program end, program end, and again rewind. So this is simple program for machining. Here from this block to this block, this is header of the program, and this is footer of the program, and this portion, is body of the program. So this is a simple program. This is how we can make the CNC program on Fanuc OT Control. Thank you very much for watching this video. Wait for next uploads. You can like or subscribe this video. Thank you again.